Hey guys, welcome back um, to another day of my challenge. Today I'm going to continue with the prefix sum that I did from yesterday. So I have this question today here. It's an easy type question, minimum value to get positive step-by-step sum. So basically the idea behind this is that you make the prefix sum of the subarray, and then you find the minimum value of that subarray, provided that the elements is not lesser than 0. So as you can see here in the example test case, um, given the input of this array, let's say that if you have a start value of 4, then 4 minus 3 is 1, 1 plus 2 is 3, 0. But as you can see, there's a 0, which is not positive. So we have to abandon this start value. And then the next start value that we're going to try is 5. And then you see that everything is a positive value. So this makes sense. So output has to be 5. So that's a way of finding a start value. Not a way, but that's what the question is expecting. Now we're going to start a code. So basically how I approached this question was just using the prefix sum. So initialize the first prefix sum, which is nums of 0. We'll make it into a list because the initial value is the same as the nums. But actually, when I started thinking, because this is the template, prefix sum, and then for I in range, um, the length of a nums list, you append the cumulative value of the nums of the elements into the prefix sum. So that's like the template, but thinking the nums value is not the same because you start with the separate start value. So I was thinking. Now I just made a separate array to keep track of the minimum cumulative sum. So it could also be seen as a prefix sum, but in the another way. So that would be minimum value equals 0. And then now we have to initialize the um, sum of the elements in the nums as well, apart from the sum that we encountered. So that would be um, total equals 0. And now we can iterate like how we do in the prefix sum. So that would be for num in nums. We add the number in the nums, the current number, into the cumulative sum, which is total plus the num. But at the same time, we have to update the minimum value in order to make it the minimum value between the total and the current minimum value, because we initially initialize minimum value as 0. So like we did during our two pointer session, um, minimum value equals min val total. As I keep on solving these kind of questions, this method seems to be very useful. So when you iterate to find the higher value or minimum value, you just use this min notation. I've only before this I've only known how to do this using list comprehension. So list comprehension, and you put the function, or by using the tools from partial, reduce, like reduce. But yeah, this is very useful. So I really recommend it. Now, what you have to do is you have to return this value, right? So you return this minimum starting value that the sum of the starting value um, is at least 1. Yes, because it has to be positive. So that means we have to do another one here, making sure that each one maximum 1 minus min. Yeah. Yeah, so just with 8 lines of code, hopefully this works. Yeah, so now it works. As you can see, for the test case 1, when you put this list of array, you get 5. Yeah, the first, if you put start value as 1, this makes sense. So how does this relate to a concept of uh, partial sum? So I mean not the partial sum, the prefix sum. So basically the sum of the start value and every subsequent element in um, nums meet the requirement as it reduces the need to uh, repeatedly iterate through nums to calculate sums. So it makes it um, really efficient. As you can see, it just um, uses the um, already defined prefix sum and then just turns um, the minimum starting value such that